Eric here with Snyk. How many times have you heard this? Don't run your containers as root. Spend any amount of time researching container image security topics, and this is probably the most common piece of advice you'll run into. But why? Isn't the process contained? Well, simply put, if a process is running under UID 0, even in a container, it, or an attacker exploiting it, can potentially do bad things. The most common issue relates to volume mounts. Let's say you have a shared volume mounted into several containers. A central logging folder, maybe? Your contained process running as root is very likely going to have full access to every path on that mount. Now imagine your application has a directory traversal vulnerability, and a hacker starts poking around your container's file system. Those are some nice config folders for another application in that other directory. Even worse, what if someone adds a host path volume, also known as a bind mount, to your deployed container? Now your root process can read and write to any paths on the host file system anywhere under that mount point. Another thing, if you are root in the container, you almost certainly have free reign in the container's file system to add or modify executables, install packages, and pretty much have your way in there. You are one remote code execution exploit away from some hacker setting up a beachhead in your container. Of course, your cluster operators can restrict host path mounts with a pod security policy or OPA rule or something like that, and they might have installed runtime protection software, but a default Kubernetes cluster offers no protections to these. So why not do your part to limit the exposure? Fixing this, in many cases, is trivial. Kubernetes SecurityContext, at both the pod and container scopes, offers a setting called Run as Non-Root. Simply add this to your deployment manifest with a true value, and the kubelet will refuse to start any image that defaults to the root user. Now my container won't start because it does default to root. Yep, now you need to change that default. First, check the base image you're inheriting from. Many official project base images have a user already created that you can simply add a user line to your Docker file to change the default to. For example, the Node.js official images have a node user at UID 1000 ready for you to use. Take note that while the user name is a valid option in your Docker file, if you are targeting Kubernetes, you should use the UID integer instead. This is because the kubelet has no way to determine what UID a given username string will be before it actually starts the container. And it'll refuse to start that container, and it'll throw a non-numeric user error in the description. If your base image doesn't have a non-root user, you can add one in your Docker file in a run line with the appropriate user add variant for your base image's Linux distribution. Just add that user line after it with the UID you just created. Don't forget to set up your image's file ownership and privileges so the process can run correctly. A common practice seen in Linux is to have executables owned by root, but readable and executable by others. This prevents the non-root process, or a hacker, from modifying them. The SecurityContext spec also provides run as user and run as group settings that allow you to override the image's default. These are the equivalent of the -u functionality of the Docker run command. As long as your image actually has the user and or group you specify, and the process can actually run as that user, then you can use these. But I recommend only doing so if you are running from an image that you don't control the Docker file for. These are not a replacement for run as non-root, and if used, should be used in conjunction with that to avoid future developers not realizing that you specifically want to block running as the root user. Now that you know why you shouldn't run as root, the next battle is finding out where you are deploying without using this setting throughout your code. Snyk IAC scanning can help you catch any Kubernetes YAML files in your code that are missing this setting, along with many other policies that you should be aware of. Just go sign up for your free account at snyk.io, and you can start scanning your code today. Restricting root is important, but it's not the only tactic available to you. SecurityContext also has settings for limiting privileges, forcing container file systems to be read-only, limiting Linux capabilities, and many others. We've published a cheat sheet that goes into details about these settings, as well as the other ones available to you in the SecurityContext API. I'll include a link to it in the description below. This video covered topics 1 and 2 from that article, and I'll be posting future quick hit videos like this one covering more of them soon. If you found this helpful, hit that like button and consider subscribing and clicking the bell to be notified when future videos go live. Thanks so much for watching. We hope you'll join us for the next one.